Okay, morning everyone. Welcome to our week 2 of MATH13218. Today we will talk about separation of variable. Right. So there is so many new concept, that we can look at. Various forms of separation of variable of differential equation. So as the name suggests, if the given differential equation, you can separate the x term and the y term, that is which we call as a separation of variable. Okay, right. So as we know, the differential equation is dy by dx is equal to something. So if I have dy by dx is equal to 2 separate term fx and gy. So if they are separate, if they can be separated, like you can see here, then we will keep the y term with dy. So this gy will go here and dx will come up. So you got dy, that's a different, you can be integrated because that's a differentiation over the y term. And then on the other side, we have fx and dx, again, that can be integrated. So you have everything in the y term, everything in the x term. Now, in terms of the integration constant c, you can keep it anywhere you like. Okay, just to refresh our memory from last year, we need an integration constant. It can be either side, it can be however you like. It can be k, can be c, c1, c2, c3. But since we are manipulating the equation after we have the constant c, and therefore we sometimes start with c1 or c2 and then change it to c at the end. Okay. Okay. So let's look at an example. Find the general solution of x y dash minus y is equal to 0. Whenever we see y dash, what we mean is dy by dx. Okay, so we start writing it in the form of dy by dx. So x dy by dx minus y is 0. Okay, so what we did, we changed the y dash into dy by dx. Right. Now, the question will never tell you that it's separation of variable. So a quick tip here is, even though you will have open book, even though you will have formula sheets and your own written notes and everything, please try to memorize certain ways of solving a differential equation. Because as a student and based on a feedback I received from many past year students, they get confused when they see a question. It could be variable separable, it could be the other one, it could be the third one, right? So in order to really be expert or really confident in solving a differential equation is you look at the question and you know, hey, this is this method, right? So if at least the concept is in your mind, whenever you see a differential equation, you will scan through all the things or make your notes in such an effective way that you know exactly what it means, right? Cool. Right. So what we do, we write x dy by dx is equal to y. Okay. And as we have separation of variable, we will separate the variable again only when possible. So dy over y, so y comes here, dx goes up, x goes down. Once you have it in such a nice form, what is the next step? Is to integrate. Okay. So we integrate both of this. Right. What is integration of 1 on y? Is ln y or log y to the base e. This is ln x. Now, for simplicity, you can write c dash, c1, or ln c. I will go with ln c, so I don't have to worry about converting everything. Okay. Still, if I need to change it, I may write ln_c1, I may write ln_c2, right? Cool. Please keep all the integration formula handy or in your mind. Okay, you will need that. Now, property of ln, you can combine x and c, and therefore y is equal to xc. Okay, so that's the solution of the given equation. That's it. It doesn't have any initial condition, so the particular solution is not possible. To refresh our memory from last week, differential equation can be solved. It will have two type of solution. One is a general one, including this C or C1, and the other one is a particular solution. So you will be given some initial condition, initial value of the relation xy, something like y of 0 is equal to 1 or y of 0 is 0, something like that. That means you will be given a set of xy value. You plug in the equation to get rid of the unknown c, right? And then you will have a particular solution, something like y is equal to 2x, y is equal to 10x, blah, blah. Okay. Now, what would have happened if you didn't choose LNC? I'll do those steps so you understand that it's all right. Whatever constant you choose, you can always achieve this final outcome. So from here, what if I had written that ln y is ln x plus c? I don't realize, and I know that I'll have to change it. So I start with c1, okay? And therefore y is e power ln x plus c1, right? Log changes to exponential, right? If it was a log, the standard base we assume is 10, that will go 10 power ln, the base is e, right? And therefore it will be e power. Remember the natural log and a common log. All those things has been covered in the previous year. You just have to go back and revisit your notes. At any point, any question, please get in touch with me. Okay. Again, follow the same pattern that we were doing last term. Whenever you see the question in the live class, I may pose it and do it if there are some students who are doing the question. When you are watching the recording, by all means, when you see the question before I start the solution, please pause the recording, solve it, and then play the recording as you go, or finish everything and play at the end. But do it with me, right? Don't look at the solution and attempt it. Then you are just recalling the memory, what you are seeing, right? The best thing is to really let your brain work, okay? Cool. Now the exponential property, we can always separate that. So that will be e ln x and e c1, or e power c1. Again, that's the definition of log. E and exponential, they are inverse function. They will cancel one another's effect. So that will be this. And I will write here c. So simply y is equal to xc. But when you do that, right, you need to mention what is this c. So you will write where c is equal to e raised to c1. Okay. And finally, your answer looks the same. Few steps, extra work. Had you not realized that I should write LNC? Sometimes you will write 10 inverse C, sometimes you will write something else. They're all constant. Pick up whatever you like. Okay? Cool. So that was our question number 1. Add some space, which I didn't need. Awesome, isn't it? Right. The next one. See, solve blah, 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 and find the particular solution where y of 2 is 2. Have you interpret this? This is the value of x, okay, and this is the value of y. X and y, okay? But that will come at the end. First of all, we have to solve it. Now, we don't know anything, so you should try. I mean, in this instance, we know they are the example of separable variable, separation of variable, but in general, no, we don't know that. So what we can do is try and first of all modify the equation, solve it. Right. So I'll start with the question xy dy plus dx is equal to y square dx plus y dy. Obviously, the first step is to collect the dy and dx term, keep them together, and simplify where you can. So I got a xy dy here. I got this dy term. This is a x square dx term, y square dx, and this is another dx term. I take common what I can, so I keep y common. Left is x minus 1 dy. And over here, y square minus 1 dx. Okay. So far, we are just simplifying it. Now, you can stop here, observe the equation, and see in your mind if you can do it. Y term on one side with dy and x term on the other side with dx. So if I shuffle this, right, if it can be taken on the other side, and if this y can be taken on the other side, right, the left and right hand side swapping, then obviously it looks like we can have y and dy separated, right? Y dy and x dx separated. Okay, so let's do it. Y over y square minus 1 dy and 1 over x minus 1 dx, right? Looks like we can now integrate this because you got y being separated on the side and x being separated on the other side. Okay, cool. Now, again, pause the recording if you're watching it. Think about how would you integrate this. Okay, think about how you would integrate this equation. Right, so I hope that was enough time for you to practice. Anyway, you had paused that, so that's all good. Let me do some working on the side rather than the next screen. Right, so on the side, we can see what's happening. I'll change the pen color to green. Okay, this is what I'm doing here, right? This is what I'm doing here. So the purpose, as I say, is to simplify the denominator. So what I will do, let y square minus 1 is t. Now, it's impossible to integrate if you got two different variables. So the aim is to integrate and converting everything the left-hand side into one variable. Okay, so what is differentiation of this? Y square differentiation is 2y, but we got a separate variable, so we write dy, and t integration is dt. Okay, 1 dt or dt, right? I have this stuff here, y dy. Okay, so can I write y dy as half dt? Okay, so what will happen? That's what we need to. Okay, so I will rewrite this for one more. Y dy over y square minus 1 is equal to 1 over x minus 1 dx, and I will use this result. Call it equation 1 if you want to. Okay, so on my next screen, y dy, which is half dt, I got integration half dt. Denominator was y square minus 1, which was t. And I'll keep the right-hand side the way it is. Doesn't need to be changed. So 1 over x minus 1 dx. I prefer to integrate everything in one step. Otherwise, whenever you integrate, you'll have a C, C1, C2, C3, you know. If you don't, then you might forget to simplify and multiply and everything. Okay, so I could have integrated the right-hand side in this step or the previous step, but then I'll have to add a constant C. So I'll keep carrying the integration sign and do integration in one step. Right, I'll keep the half outside. Any constant can wait outside. 1 over t dt, 1 over x minus 1 dx. Easy to integrate. Whenever you got 1 over x or 1 over something, integration is ln of that term. So this is half ln t. Ln, I'll write the modulus because log cannot assume domain or the internal value as negative. So the absolute value will ensure that is always positive, right? And again, you could have gone with C, But like I showed in previous example 1.7, it's whenever you have log on one side, it's better if you have ln. Okay. And also, what do you think of half lnc? Because I'll have to get rid of this half as well. Okay. So that will save you even more time. Again, you can rerun the scenario by simply having C or LNC. I chose half LNC because there is a half in my T. Okay, right. We simplified. Right. So first of all, half LNT. I'll times everything by half. Yeah, or times by 2, sorry. Therefore, LNT is equal to 2 ln x minus 1 plus LNC. Okay, LNT, the 2 property of log. Anything in a power will come in a multiplication. Anything in a multiplication can be taken to the power. So this will be ln x minus 1 square plus ln c. Why did I remove the absolute value or the modulus? Because now it's a square. Square will also ensure that the internal value is positive, right? So I don't have to write modulus n square, right? The absolute value or modulus, which we call it. Modulus is for the vectors. I don't want to confuse that. So absolute value square is not required. Either you have absolute value or you have bracket and a square. Okay, right. Again, log property, addition can be multiplied. So ln x minus 1 square I write like this, c times x minus 1 square, combining. Yeah. And from there on, since it's both side ln, I can get rid of it. T is equal to c x minus 1 square. Now remember, like this is how I say it in a common language, so I don't forget, and I think no one should forget. T is a borrowed variable. You assumed it for your convenience. Someone else would have assumed D or Z or P or Y, right? Or M or N or anything, or alpha, beta, gamma, all the Greek alphabets. That was not a part of question. Anything that you borrow should be given back. It's like borrowing money from someone. You should return it, right? So T was a better variable. Please remember to put it back. What was our T? Y square minus 1 was our T. Okay. And therefore, y square minus 1 was c x minus 1 square. Okay. If the question was only general solution with no value given, they would simplify it here and get y is equal to something, because this is what the question is expecting you to do. But since I have to go a step further, right, it's easier for me to substitute the value in this. Okay, so I'll tell you what I mean. Okay, I'll call this equation 2 for now. Okay, I got 2 more squares. I'll rewrite equation 2 on the next stage. So y square minus 1 is equal to c x minus 1 square. Now, do you understand the importance of this half LNC? If you had not done it, there will be c like 2 in the front and LNC square, and c square will be replaced by c and all that thing. Okay, right. So technically, I'll do it as if there is no particular solution. Okay, therefore y square is equal to c x minus 1 square plus 1, and y is equal to plus or minus square root of c x minus 1 square plus 1. This will be my final answer if there was no particular solution required. But since I have this additional condition and I have to find a particular solution that should not involve the c. Okay, right. So this is my part of the answer, but I have to obtain the value of c. So what is my, I can use this. Now I give you 2 choice. Okay, I'll give you 2 choice, and anyone who is more sensible, logical. If you have to obtain the value of c, what should be your choice? This or this? right? If I were a student, I would refrain from opting value from plus or minus or the root. My choice will be this because my aim is to obtain C. I could have used this equation, I could have used this or that one. Obviously, my choice is this. Okay, so what I will do, I'm given y of 2 is 2 on top of my memory. Yes, y of 2 is 2. I'm given y of 2 is 2. Right? As I said, my choice is this. This means this is a x value, this is a y value. That means when x is 2, y is 2 as well. Okay? This is again x. This is my y. Okay? Inside is x, the right hand side is y. Wherever you see x and y, replace these values. So 2 square minus 1 is equal to c. 2 minus 1 square. 4 minus 1 is 3, and this is 1 by c is 3. Now, the final answer, you must use the y value. And therefore, y is equal to plus or minus square root of c, which is 3x minus 1 square plus 1. Those who wish can also simplify this even further. 3x square minus 6x plus 4. You expand it and add 1. Not required, and therefore this thing here will be treated as our final answer. As we progress in the content, you might find it's getting a bit difficult. If you don't follow it along with the required reading, watching the recording, practicing the question, and the follow-up textbook question, you will struggle. That's for sure. Okay. Right. Okay, let's keep going then. Now, this is like a more practical application. I like questions like this because this is why we are learning maths. We are not learning maths just to our ability to solve a question if it is really not applied. I mean, there are two branches of maths. One is a pure maths, other is applied math. Many of my bachelor study, what I did was applied maths, pure maths, not really applied. But then later on, I understand the difference and importance of pure maths as well. But as far as the teaching courses are concerned, it will be all applied. You know, you will definitely apply it at some stage. Okay, right. Again, to go back to our previous term where we talked about linear algebra and system of equation, what did we observe there? If there is one unknown that you have to solve, you will get one equation. If there are two unknown like x and y, c1 and c2, c and d, or a and b, you will need two equations. It can be the other way around as well, right? Most of the information in an example, in a question, will be relevant to how you solve the question. So if the question has given two values, right, I would assume safely that there'll be two unknown, like C1, C2, or C and D, or A and B, however you like. Okay, but two particular conditions, that means there has to be C1 and C2, or K and C, or A and B. Take it what you like, but there'll be two, that's for sure. Okay, now we read word by word and try to make sense from it. The pressure P of a gas in a closed container is related to its temperature. Right? So pressure and temperature are related. Okay, not inversely related, related. Okay. Now it says further how they are related is coming now. The ratio of the change of the pressure to the change of temperature. So again, I will stop reading here. Ratio, that means division of change of pressure. What do you mean by change of pressure? dP. Change of anything is d of that variable. Ratio of change of pressure, that is dP divided by, or dP over change in temperature, dt. dP dt, change in pressure, change in temperature. So here we are talking about dP over dt. Small t is time, capital T is temperature. Okay, that's a adopted notion. P is pressure, adopted notation. Right. Now that one is proportional to the pressure. So it's proportional to the pressure, right? It says further, and C is in capital, so can't miss that. Inversely proportional to the square of the temperature. Inversely, so it will go in denominator square of the temperature, right? You could have written it two separate equation and then combine it. I could say that dP over dt, change in pressure over change in temperature, because it says ratio, varies to or proportionate to change in pressure. And this one is also inversely proportionate to the square of the temperature. And therefore, I can say together, I can say that dP over dt is P over T square. Year 7 math, where you have two separate proportions, you can combine. Okay, proportionate to, not the proportion, not the ratio. Right, that's it. That's your part here. Then the question started. Find the general relationships. So something with a constant C or CD or C1, C2. And the temperature. Find the general relation between the pressure and temperature, P and T, because that's the only two variable. Once you find the general relation, you will go further and find the particular solution based on two conditions. Now, please remember to address all parts of the question. I'll analyze question once more because this is not the only question you will get. Yeah, you will get similar question or a different nature question. So apply this technique or approach. Pressure P of a glaze in a closed container is the related temperatures P and T. We are talking about P and T. The ratio, that means your mind should say we are talking about something or a division, right? Of change of pressure, dP. Change of pressure, dP. Ratio of dP to the change of temperature, dP over dt. That's what I'm talking about. A is proportionate. This is a symbol of proportionate to, not an alpha, symbol of proportionate. Yeah. To the pressure, that is 2P, like I written here, and inversely proportional, that means it's going in denominator to the square of the temperature, or 1 over T square. Okay, then you combine this and make an equation that dP over dt is P over T square. You got an equation that is still in proportion, but you got an equation. I mean, you can get an equation from here. Then find the general relation. That is what we are doing, including the constant C, if that is more than one, C1 and C2, and the temperature of this gate. So you will find the general relation, and further, you will find a particular solution of P of 10 is equal to 100, P of 20 is equal to 90. Again, what this means, that P is your dependent variable on the temperature, right? So this is your T, this is your P, this is your T, this is your P. Okay? This will be a higher marks question, which can come with advantage and disadvantage. If you can nail it, hooray, job done. And if you can't, you'll be like, oh, I missed that. Yeah. So please choose it wisely. Choose it wisely. Yeah. Okay. Right. So let's give try. Let's first of all. So we developed the basic stuff. I'll continue writing it. So what we know so far is dP over dt is proportionate to P over T square. Now, in order to remove the proportionality, I need an equal to sign. Okay, so for that equal to sign, what I will do is dP over dt is equal to K. Normally, we adopt K as a proportionality constant. Kp over T square. Make sure it's capital D. Right. So that's your differential equation. In earlier question, the equation was given. You are simplifying it. In this question, we had to create the equation. Okay, so dP by dt is equal to Kp over T square. We arrange it. dP over P is equal to K dt over t squared. Okay. Now we integrate this. Remember, k can stay outside. Any constant can stay outside. See?
Where did k come from?
Proportionality constant in order to remove the proportionality, because this is nothing. It's like, oh, when the interest rate is going up, your price will go up.
Yeah.
Like in the recent economy, we always see that inflation is rising. Why? Because the cost of living is going up, couple of factors. But by what percentage? Simply the relation of population goes up, this will go down. Population goes up, prices will go up, like that, right? But I don't know the connection that by 10%, by 5%, by 20%, So you need an equation to equate that. So it makes sense. Yeah. So that's why in order to remove it, from proportionality, we write equal to, and we have a proportionality constant k.
Okay, cool.
Right. Now, so we kept the k outside. Now, run refreshing time. Yeah, you can pause your recording if you want to and refresh from our memory. What is the integration of this? Right, so x power n dx is equal to x power n plus 1 over n plus 1 plus c. C is always there, yeah? Not she, c, okay? Right, so why it's important? Because I got t power minus 2, right? So x power minus 2 dx will be, you increase it by minus 2 plus 1 divided by minus 2 plus 1 plus c. Okay. Just a quick tip, if you ever get confused with differentiation and integration, of course you will have formula sheet, but I don't prefer to refer it as I go. Like something has to be in your brain. That's why we think, right? Not just to go flicking pages and, like every time referring to it is not a good practice. So whenever you get confused, remember D is decrease, differentiation is decrease. So when I talk about differentiation of x power n, I will say nx minus 1, and x power n minus 1. So I decrease the power. Integration is the reverse. So in integration of x raised to n, I would increase the power. In differentiation, I put it in multiplication, n times x power n minus 1. In integration, I will put it in denominator, not in multiplication. Okay, right. So we change this. What we do is, I will write it once more. Oops, has to be capital T. Please observe your writing, okay? Capital T is temperature, small t is time. Now I'll integrate using this formula. dp over p has to be ln p. This is t power minus 1 divided by minus 1. K is there already. N plus c will come in place, or ln c, up to you. Doesn't matter. Yeah, we will change it anyway. I'll keep it c just to give you a feeling of what would happen if you forget of writing ln c. Okay, let's simplify this a bit. So minus k over t plus c. T will change it to exponential minus k over t plus c. Break it down. Exponential property. And just write like this. And up here, e raised to c, I'll call it c1. This is the general relation where c, why not write a c1 here and write c here? Yeah. Right, so I got the relation P is equal to C e raised to minus KT. Now remember what I said when I was starting with the question? I look at two equations. That means I will have two unknowns, two constant, which I have to replace. I got C and K. P and T are the variable, they can't be replaced. They will assume a particular value, but that's only for a time being. But otherwise, it's like a point on a line. So you can say xy is 1 and 3 on a line, but that's only to identify the intercept or some other property. But then you'll always write y is equal to 2x plus 3. Same thing goes here. P and T are your variables. C and K are your constant, right? Someone else would have assumed L rather than K, C dash rather than C, or D rather than C. That will not change. I mean, that can change, but P and T will not change. Yeah, cool. Now we go one step further. What is the next step? What we will do now? We will replace the values given. So this is a part of the question. The question says, find the general relation between the pressure and temperature of the gas. Halfway done, you found the relation using integration variable separable technique. Now, find a particular solution if two values are given. So this is what we will do next. Okay, so I'll write the question on here. E is equal to C e raised to minus K over T. The relation given was, sorry, what was it? P of 100 was 10. P of 10 was 100 and 20 is 90. Mhm. 10 is 100 and 20 is 90. Okay, right. Two equation, two unknown. So again, this is the value of the variable T and P. T and P. So that is equal to C e raised to minus K over 10, and the other bit is 90 is equal to C e raised to minus K over 20. Okay, I'll take the division. Okay, however you solve it, this is exponential, right? But not based on a calculator. You need to show steps. Okay, so 100 over 90 to C e raised to minus K over 10. You can simplify it in decimal if you like. So 10 over 9, C is gone. E raised to K over 20 minus K over 10. Subtraction of the power. Or did I do it? Yeah, this is right. So, okay, if you wanted to write in a way it makes sense, so minus K over 10 minus of minus K over 20. So 10 over 9 is equal to E raised to K over 20 minus K over 10. E becomes log. So ln E raised to, what is the simplification of this? K over 20 with a minus, isn't it? Yeah. Okay. And then once you simplify this, you will have the value of K as, what do we get here? Okay. Can you solve this for me, please? So K is equal to minus 20. Oops, why do I have both? Sorry, my bad, my bad. Okay, K is equal to minus 20 ln 10 over 9. Can you find me a value of this in your calculator, please?
Yeah. Negative 2.107.
Great. That's the value of K. Okay. Now, I will use this in any of this equation to find the value of C. Okay. I'll go with the 100 because that's a bit easier. So 100 is equal to C e raised to minus K over 10. Okay. So can I say it 100 times e raised to K over 10? So technically, because there is a negative power, it will, okay, if you want, I can write a step, right? 100 times e raised to K over 10 is C I would prefer to write this value. I don't know why, but let me, rather than decimal, even though decimal makes more sense, I will choose this value, okay? Times e raised to minus 20 ln 10 on 9 is C. Okay, well, the next step is 100 e raised to minus 2 ln 10 on 9 is C. Yeah, the power goes in multiplication goes in power, the multiple ln 10 over 9 power negative 2 is C. Yeah, E and ln will cancel one another. So simply 100 times 10 over 9 negative 2 is my C. I flip it 9 over 10 squared because there was a negative power, so you can flip it. So 100 times 81 over 100 is C, and therefore C is equal to 81. That was the reason I chose K value in log. If you're a fancy calculator person, you can replace it here and simplify it and get the value of C as some number. And I'm sure that will be 81. So I got my K, I got my C. So finally, the pressure P, I will use this bit, okay? C, which was C, what is C? 81 e raised to minus K over 10. What's a K? 2.101. Or you can write this K over 10. So that will be C, I got it. E raised to minus K over 10. So can I say 2
15.
ln 10 on 9? No, something is missing. What is missing? K over T, sorry. Where's my T? Okay. Sorry, I'll write the question again. Not the question, this equation. C e raised to minus kt. And then I'll plug in the value. So that's my general solution. This is 81 e raised to k, which is minus 20 ln. Just simplify this a bit. 81 e raised to 20 ln. That's it. If it is a bit hard to read, what you can also do, all right, exp exponential of 20 ln 10 on 9 whole divided by t. That's another way of writing as well. At least I will adopt it. So this is your two of the answer. Either you write particular solution, any of this way, and this is the general solution. Yeah. Like I said, the question will increase in difficulty. So if you are struggling with the basic concept that, oh, what is differentiation integration or how you replace the variable, all this thing, it's a perfect time to revisit those concepts. It's not that you don't know, it's that you might have forgotten it, right? So refresh those, so at least that portion will be settled off, and then you are ready to absorb some new concept. Cool. Okay. Okay, one more example of variable separable. There are many ways of saying it. Variable separable is one way. Separation of variable is depends on an author. I was referring to so many books. When I say so many, at least 10 different author book where you find one or the other terminology. As long as you know what it is, it's fine. No one will ask you that justify what you're saying. Right? Cool. The current I in an RL circuit, you know the RL circuit, right? Something that, oops, something that goes like this. That's the T part. We've got an R here, L here, and the current flow is I. Yeah. Okay. In the RL circuit, with a constant input E is defined by this. Okay. L is inductance, R is the resistance, E is the voltage of the supplied. Find the current given. I of 0 is 0. So it doesn't specify general solution, doesn't specify a particular solution. Everything by now you should be aware. But whenever it has this, that means, see, this will indicate you who is the variable. It says L is the inductance, R is a resistance, E is a voltage, right? With a constant E, R and L, constant. So they are your constant, whatever, 5, 10, 15 or whatever, right? It's unaffected. Your variable is INT, okay? Your variable is INT. So you'll talk di by dt. That indicates this is the variable T and this is the variable I. So you will start with finding a general solution and towards the end you will find the particular solution. Okay, let's get started. First thing first, di by dt is equal to R over L. R over L, I is equal to E over L, dividing by L. Okay, now is equal to E over L minus R over L I, or I can say E minus R over L I. This will tell me, did I do it right? No, RI here, sorry. Right. Yeah, only L is common, E minus RI. This will tell me that I can have a variable separable. This is the only E term on the top. I'll bring it in the denominator and T is all alone. There is no other T term. So my next step is di over E minus Ri 1 over L dt and then integration. Now, again, pause the recording after this. Okay, not now, sorry. I'll ask you a question, then you can pause this. What is integration of 1 over a plus bx dx? Not looking at the formula sheet, using your brain. Think about it, think about it, think about it. Okay, if anyone has guessed it right, 1 over a ln of a plus bx plus c. If you don't know how that works, what you can also do is assume a plus bx is p. That will tell me b dx is dt, or simply dx is 1 over b dt. I put it back here, so that will simplify to 1 over b dt over t. Leave the 1 over b outside, 1 over t dt. Of course, we will integrate this ln t plus c and t, which is our a plus bx, 1 over b ln a plus bx plus c. So that's a proof. Had you not known it, or had you forgotten, how to integrate this? But, oh, my bad, typo. 1 over b, the multiple of x, yeah, not the constant. 1 over b a plus ln x. So obviously it's important to have this as a part of formula sheet somewhere rather than doing this long bit, because this is a part of the question, it's not the question. So obviously don't spend time in doing unnecessary work. 0 marks for this additional work. It will take time. If you get it wrong, you will lose marks, right? Okay, so integrating it here, what it will be? So multiple of I, which is my variable, is minus R, remember. So minus 1 on R, ln E minus Ri, 1 on L is a constant, plus C. Okay, I will multiply it by minus R. I call it C1 to start with here. So ln E minus Ri is equal to minus R over LT minus RC1. Still, I have to take care of a log on the left-hand side. So how about I still carry on E minus Ri minus R by L3 plus C2, where RC1 is my C2. Yeah, negative RC1 is my C2. It's a bit less horrible. Ln has to be converted into E. So E minus Ri is exponential of minus RLT plus C2. Change it. Okay. So E minus Ri is split it. E raised to minus RT over L and E raised to C2. Okay. E raised to C2, can I call it C? Yes, you can if you want to. C E raised to minus RL over T. Okay. Remember, I am focusing on I and T. I need a relation between I and T. It's still a bit messy. Let's make it even messier. Sorry, let's make it clean. Okay. I shuffle Ri and E. So E minus C R over LT is equal to Ri. I'll divide by R because I need I. So E over R, C over R, E raised to. This is my relation or the general solution. I is equal to minus C on R, E raised to R over LT with a negative up front plus ER or ER minus this. Yeah. Now, we are given some particular conditions. What is it? 0 is 0. Simple condition. T is 0, I is 0. Okay. Now you will write I of 0 is 0. That means T is 0, I is 0. Plug it back here. I'll do it in this screen rather than next. So E over R, they are constant, does not change. C over R does not change. E raised to 0 times something, which is 0, is equal to 0. So E over R is equal to minus C over R is 0. E over R is equal to C over R. Therefore, E is equal to C, which I'll replace in this equation. So what it will look like. So finally, E over R, C. Here is a question. What should you replace, E or C? Again, think about it. Pause the recording if you're watching it. What should you replace, E or C? Those who guess C is right. Why? Because C is my variable, not the question variable. Someone might have taken K as a constant of integration, right? Or C1 or C2 or C3. So there are a lot of variation based on a user or a student. Well, E is from the question, which I will not replace, right? And therefore, E over R, E raised to minus R over LT is I. Okay, I'll just simplify it to write it in a way it makes sense. So I take E over R common, 1 minus R over L T. That is my final particular solution. Remember, here we are using small t because that's based on time. Capital T is for temperature. Don't mix it. Right? So wasn't that intense as the previous question, but more applied question. Okay, okay, I got one more method, which we will do it in a bit. We'll take a short break here. Those who are watching, you can take a break whenever you like. Just pause it. It's a break time. Okay, let's continue our discussion. So the next part of variable separable is, so far what we have seen was kind of obvious variable separable, where you can really make it out that this is, can be separated. Now we will look at some advanced form of where you can convert an equation into variable separable. So it's not variable separable, but you can always convert that. Okay. Am I still sharing my screen? Can you see my screen?
Yeah.
Okay, cool. Yeah. Okay. So if the ODEs, so here we will be talking about solving which is on y on x form. So whole equation can be returned as a variable y on x. And then I'll share some tips of how you will observe it. Okay, right. So you will suppose y on x is equal to some variable. Yeah. Like y on x is equal to u or t or whatever you like. Okay, you will replace that, and then y is equal to xu. So rather than xy as your variable, your new variable will be x and u. Okay, so you will convert everything in x and u. Remember, you can only have two variables, y on the left side, x on the right hand side, or u on the left side and x on the right hand side. Yeah, don't mix y, x, and u, otherwise it's more complex. Okay, so let's look at how it will go. Okay, so you will replace first of all u is equal to y on x. So when you look at that, what will happen? This is like this. So dy by dx will be g of u. So you got y, x, and u. Okay. So we are making it complex. So that's not a good way. So what we will do, u is equal to y on x. That means y is equal to x and u. Okay. I will differentiate this with respect to x. What will happen? dy by dx, the product rule. X stays as it is. Du by dx. And then u says as it is dx by dx, so the differentiation of x is 1. So my dy by dx can be replaced in some form of x and u. So this will be u plus x du by dx is equal to g of u. Then you take the u here, and then it's variable separable. Okay? The example will make more sense. The theoretically x, y, and u, what's happening, it will not make great sense. Okay? Right, still there is a steps. What's to be done? Y will be replaced, y on x will be replaced by u. So the whole form of the given differential equation, right? What will happen? This is the steps that I have done. U plus x du by dx, right? This will be your g of u, because rather than this, what will happen? This is your dy by dx, right? And this y on x is your u. Then you take the u on the other side. So what will happen? X du by dx is gu minus u. And then it's a variable separable du over gu minus u and dx over x. Right? Like I said, it will not make sense. Only two key takeaway from here. Replace y on x as u, number one, and then convert dy by dx into u and x. That's only two things. Don't worry about. Even though it's there for a reason. But if you get confused, don't worry about it. Focus on a method. Okay? Right. One thing that I must tell you, and that's a key message here, if that's not there, this method will not work. The combined power of x and y term should be the same. What I mean by that, here you got two power, Here you got 2 power, 1 and 1, 2 power here as well. Okay, if that doesn't happen, this method will fail. Either there is some different method or there is a typo or something, but this approach will not work. One more example, I will tell you. 1 and 1, so 2 power here, 2 power here, 2 power here. That's your first point. If that's not there, your y on x is equal to u substitution will not work. Absolutely not. Let's check at the next one. I'm not sure. Nothing given here. So yes, this two example. Then when you follow the textbook, the reference book, please observe it as your starting point. Okay, right. So that's a key takeaway. Now let's look at and solve it. Okay, let's look at the method and try to solve it. Right. First of all, let's create in the y on x form. See, you don't have to convert in the y on x form if you can get away with doing other ways, but you will not be confident doing it. What I'm saying, I'm confident looking at this question that I will be able to use y on x form and then variable separable. Then I can simply write y on x is equal to u, y is equal to xu, wherever I find it, and convert everything from here. That will work. But if you are not confident, bring it in a y on x form. I will do both the steps, right? I'll do both the steps and then tell you what I mean, right? Okay. So what we do, like a new kid, we don't know anything. We start with converting first of all and checking whether it can be separated in y on x or not, which I know it can, but you'll have to check it yourself, right? So x squared plus y squared dx is equal to xy dy. As usual, we will keep dy by dx on one side. And that means x squared plus y squared over xy, isn't it? Yeah. Okay. So this is dy by dx. Now up here, I have to bring y on x. What is the highest power of x? Is x squared. I will divide the numerator and denominator by x squared. Okay. X squared over x squared is 1 plus y squared over x squared. And over here, x is gone, y on x. So what I got is dy by dx is 1 plus y on x squared over y on x. Or, sorry, not square. Or, if you want, 1 over y on x plus y on x. You can even write it further. Now, is this of the given method form, y on x form? The answer is yes, because everything on a y on x, everything on the right-hand side is of the form y on x. So when you assume y on x is equal to u or t, the differential equation can be converted into that form. Okay. Now, do you understand the reason why I said power should be same? If it is not, you divide it by the highest power and some x will be left over or some y will be left over, which would be a problem converting in this method, right? And that's why what I said, the power 2, 1 and 1, power 2 should be like that. Otherwise, this method will fail. Okay. Right. What we learn in the method, we assume y on x is equal to u. You could have gone with t, that's fine. T is my preferred over u because y, x, and u look similar. But anyway, we stick to the method and then convert the whole equation in the x and u form. Okay, right. Let y over x is u, and which means y is equal to x and u. dy by dx. It's there in the method as well. You can write it directly if you want. Differentiation with respect to x. So x becomes 1 and this is x d by dx. Equation 2, I call this equation 1. From 1 and 2, what will happen? Dy by dx, that is u plus x du by dx. I believe that was 1 on u and u, 1 over u and u. Y on x is u. This u and u will be gone. So x du by dx is 1 on u, which will then be u du is equal to 1 on x dx. Okay, variable separable. Now we can integrate it. So u du is equal to 1 on x dx, u square over 2 ln x plus c1. You could have called c1 doesn't matter. So u square is equal to 2 ln x plus 2c1. Okay, and therefore u is equal to, I don't need u, I need y on x, right? So I will write y square over x square. Remember, u is a borrowed variable. Someone might have taken t, someone might have taken p, alpha, beta, we don't know. Put it back. Yeah, 2 ln x plus 2c1. I'll keep on carrying c1 unless it's a final simply. So y square is equal to x square 2 ln x plus 2c1. Okay. I think I can put it back. Therefore, y is equal to plus or minus x square roots of 2 ln x plus 2c1, or I'll call it c. That's my answer. I assume I'm not given any condition of x and y. No, no condition. So this is the general solution. That's it. Okay. I got a slide here. So I'll try to squeeze in the another approach of solving the same question. Like I said, I am confident in this question that not because it's here in this section, just because of my trick that I shared with you, that whenever is of this form, 2 power, it can be converted in y and x form, right? So alternate approach of solving, I change pen color, change it to green, write or here, a different method of solving it. Okay, I need to write the question to start with. X squared plus y squared dx, xy dy is equal to 0. Like I said, I'm confident that I can solve it with the method y over x is u. Okay, I know y over x is u, and therefore y is equal to x and u. And from there also, dy by dx will be u x du by dx. In question 1, 2, and 3. From 2, 3 into 1. Or you can say from 1, 2, and 3. I'm using 2 and 3 into equation 1. Okay. X square will stay x square. Y square will be x square u square. Okay. How about I write like this? Dx I'll write one more step here. That means x squared plus y squared is equal to xy dy by dx, because I got a value of dy by dx. That is my equation 1. Okay. Right. So x squared plus y squared. X, y is xu, and dy by dx is, what is it? U plus x du by dx. Okay, I'll keep x squared outside. So 1 plus u squared. This is x squared u in a bracket u plus x du by dx. Get rid of the x squared. Okay, so 1 plus u squared is equal to u squared plus xu du by dx. Just simplification. Yeah. Again, u squared is gone. So 1 is equal to xu du by dx. And that will tell me that dx over x is equal to u du. And it's the same thing here. Once I integrate dx over x is equal to integration of u du. This thing here. So why is that helpful? I'm saving the pain of converting all the steps. Had you been confident, if you realize that this is of the form y on x, you don't have to convert the equation in the y on x form, because ultimately it's all simplifying. You do like normal steps, and with a few steps, you'll reach to the same stage of integration. Choice is yours. To begin with, I would say, keep going like normal steps, like I had done in the original method. Once you become confident after good practice, by all means, because I'll be the one marking your assignment, marking your final exam. And I believe I'm smart enough to understand the difference and your maturity in the content. So if you approach it like this, that's fine. As long as your consequent step makes sense, I won't penalize you. Yeah, I'm not here to penalize your work. I'm here to encourage you to adopt different approach. And that's what will help you when you go in a classroom as well. A student comes up with a different approach. You say, no, 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 this is not what I taught in a classroom. And they will judge you that, hey, he doesn't know or she doesn't know. Yeah. And trust me, students are smarter than you. I dealt with some student, very young age, they pick up mistake in the material. They come up with a different approach. If you're not confident, if you're not smart, they will laugh at you. Maybe not in your face, but they will definitely laugh at you on your back. Yeah. So be prepared. Only hard work is the key. Yeah. Otherwise, we say, oh, students don't listen to me. They don't pay attention in my classroom. Because you have to earn that respect. Simply standing in front of them just because you got Bachelor of Education and they don't, doesn't win you, doesn't give you enough age. They don't care whether you are a Bachelor of Education, Master of Education, or a PhD. What they care is, are you able to improve their knowledge? Are you able to handle their doubts? Show them some fancy way of doing it, right? If you go for the same bookish stuff, what's there in the book? Why do they need you? And nowadays there is AI. Trust me, if you don't go with the upper age technology, you'll be thrown back. Kahoot is there. Tons of AI tool, I would say. You write a question, step-by-step solution. Like I was telling in the last term, inverse of a metric, step by step, exactly step by step, cofactor of each of the element. This is how you find the determinant. Put it back, step by step solution. Why do you need a teacher then? Unless you can make a difference, then you are replaceable very easily. Not maybe now, 5 years, 10 years, gone. You're very young. So do something that wins their heart. That is how you will retain your job. Yeah. Okay, cool. Right, so that's two different methods for the same question. We got two more example. Let's keep going. Okay. Again, I'm not doing both the approach in this question, but I'll do the traditional one, the more standard one, because most of us are new with this content. Okay, right. Cool. Next thing, 2xy dx is equal to plus y square minus 3x dy is equal to 0. Right. Let's convert it. So 2xy dx is equal to, or I'll write a minus here, y square minus 3x square dy. Right. Or you could have gone with 3x square minus y, so it doesn't matter. Right. So 2 2xy 2. This is funny. Okay, I will leave a line blank. This is crazy. It's annoying. Okay. Please work. Okay. 2xy y squared 3x squared dy by dx. I take away the minus and divide it by, remember, I need y on x or x on y. Yes. Okay, so I divide everything by x squared. Okay. Before that, I take care of the minus sign. Okay. Not yet. Sorry. Sorry. Okay. It's facing some technical issue. I'm not sure if it's solved, but let's have a look. So again, converting dy by dx. So 2xy y square minus 3x squared is equal to dy by dx. Okay. I'll take care of the minus sign first. So 2xy is equal to over 3x squared minus y squared is dy by dx. Now dividing by x squared, both the numerator and denominator. So how will that look? 2xy over x squared. Right? Okay. Get rid of the x or x squared where possible. So this will be 2y over x squared gone, 3y over x whole square is dy by dx. So as you can see, on one of the side of equation, you have everything in terms of y and x, and other side you have dy by dx. If you can achieve this step, that means the whole equation can be converted using the relation y on x is equal to u. Okay. So let y on x is u straight on. Since you will have your formula sheet, you don't have to go for additional steps, save your time. You can say y is equal to xu, and therefore dy by dx will be u plus x du over dx. You won't need this bit because you already converted that in the y on x form. Okay. So this will be 2u over 3 minus u squared is equal to u plus x du by dx, right? I call this as equation 1, maybe 2 and 3, from 1, 2, and 3. Take the u on the other side. So 2u, 3 minus u squared minus u, x du over dx. Simplify where you can. 2u minus 3u plus u power 3 over 3 minus u square. Yeah. Okay. So that will be u power 3 minus u divided by 3 minus u square is equal to x du by dx. Okay. Okay, so we keep going. This is hard. Okay, so before I proceed, I will just tell you that this is going to be tricky unless there is another option as well, which I was working out, but we'll see. Okay, which one is better? You decide. I'll give you two approach of solving it. Right. So we write in a nice variable separable form. So what that will look like, dx over x is equal to um, 3 minus u square over u3 minus this and d. And then we will integrate. Okay, so I'll write that bit again. The left-hand side is simple in a dx over x. It's only the right-hand side. 3 minus u square u3 minus u du. Now here, where the most pain will come. Unless you are a pro and you know how to solve it like really efficiently and quickly, this method can really hunt you down. Okay, so I'll change my pen color, go for green, and on the side, I will explain that. So that's called integration by parts, where you are, sorry, partial fraction integration, not integration by parts, where you are dividing your denominator into linear factor, right? And then building up from there. It should be your last week, last term, last year, sorry, where you are dealing with calculus. But if anyone wants more detail, more practice, clarity on this method, please get in touch. Okay, so there are various ways where you can integrate. There is no direct way of doing it. If you had assumed your denominator as t, for example, then its differential will be 3t squared minus 1, which is not your numerator. So that's not happening. T over dt over t is not happening, right? So then you will break it down. So how would I integrate 3 minus u squared denominator? If I take u as a factor, then it's worked out 3u squared, u minus 1, and u plus 1 du. Now, as you can see, there are three linear factors. Okay, so I will separate them out. Forget about integration for now, okay? 1 over u minus 1, and u plus 1. Okay, remember that ABC method where you would have written A over X, B over X minus 1, C over X minus 1, and then you cross multiply, assume X as 0, X as 1, and X is equal to, that's the same method. But since it's a part of the question, I'm giving you a trick. I'm not sure if anywhere else you will find it, not at least in some Australian book, because this I obtained through years of teaching. Okay, right. So what you do, you let it, how do you make this 0, u is equal to 0? You replace it here. Okay, so what I'm doing is I'm letting my u is equal to 0 in this first part. So if u is 0, don't worry about this, ignore this. Okay, 0 minus 1 is minus 1, 0 plus 1 is 1. So my denominator is minus 1. 3 minus 0, which is 3. So therefore, I will have this part as minus 3. Okay, then this is the value of a, b, c. You can adopt that longer method which you learned last year and obtain the value of a, b, c, or whenever there are linear factor, this will work as well. If I'm talking about u minus 1, I'm letting u is equal to 1. So ignore this factor. Everywhere else, write u is equal to 1. 3 minus 1, so that's 2 in the top, 1 and 2 here. 2 over 2, that's 1. Of course, du is there. Du. Now, how do you take care of this? U is equal to minus 1. Replace it everywhere. 3 minus 1 square, so that's 2, minus 1 and minus 2. 2 over 2, so that's 1. So there are 3 things that will happen. Up here, I will take u is equal to 1. Up here, I'll take u is equal to minus 1. And then I'll integrate it. Okay. So before I do that, before I do the integration, I will split that. So minus 3 over u do u, 1 over u minus 1 du, and 1 over u plus 1 du. Okay. What will happen now? Integration. So this is ln x, 3 ln u minus 1. Of course, I'll write modulus ln u plus 1. And since everything is in ln, I'll write ln c, right? So can be taken care very easily. I'll simplify all the right-hand side. So x is equal to u power minus 3, ln in the front as well, u minus 1, u plus 1, and c. Get rid of the ln. On the left-hand side is not x, sorry, is ln x. Therefore, x is equal to u power minus 3, u minus 1, u plus 1, and c. Simplifying it, u square minus 1 over u3 plus, times c. Now replace u back. U is y on x. Yeah, u is equal to y on x. Replace it back. So this is y on x square minus 1, y on x power 3, y square minus x square over x square, x3 over y square, and c. Yeah, get rid of what you can, and that would give you y power 3 is equal to c times y square minus x square. That's your general solution. But remember, we have to find the particular solution because the question said y of 0 is 1. Y of 0 is 1. That means when x is 0, y is 1. So y power 3 is equal to c times y square minus x square. So 1 is equal to c times 1 minus 0. That means c is equal to 1. I put it back here. Y power 3 is equal to y square minus x square is my solution. Okay. Now, had someone been not able to do this efficiently or quickly or correctly, done. End of story, end of matter, right? So that's why you need to revisit everything you learned in last year. I'm not sure term 1 and 2, sorry, I didn't teach that. But please make use of that. Whenever there is a linear factor, always adopt this technique. Okay, and then once you know that, just integration is a easy part. But that's really lengthy process, right? There is an alternate way as well. Okay, let me do that one. But it's very hard to realize. Oh, what was the question? 2xy dx plus y square minus x square dx square is 0. Okay. 2xy dx is equal to 3x square minus y square dy. See, it doesn't absolutely say that you need to go for y on x is equal to u. You could have gone the other way as well. X over y is equal to u. So let's try that approach. See if that one is better than what we did. Okay, so we divide by xy first of all, right? Dividing by x times y. So what will happen? 2 dx is equal to 3x square minus y square xy dy. So 2 dx is equal to 3x over y minus one of the y is gone, y over x. Okay, so let's try the new approach. Rather than saying x over y is equal to u, just in order to avoid the confusion, I'll go with v. Let v is equal to x over y. Okay, and therefore x is equal to vy. I forgot dy here. Dx over dy is equal to v plus y dv by dy. So equation 1, 2, and this one. Okay, I will rewrite this. So that will be 2 dx over dy is equal to 3 times x over y minus y over x. Okay, what is dx over dy? V plus y dv over dy and 3v minus 1 on v. Please remember or understand the purpose of introducing this y on x or x on y. Because you don't have any method of integration or solving this differential equation, so you are assuming your y on x or x on y is equal to something, and therefore the variable can be separated. But nowhere it says that it has to be y on x. If you prefer so, it could be x on y. Okay, now let's simplify where we can. So what that will be. Let's expand everything. 2v, 2vy, dv over dy, 3v and 1 on v. Okay, let's take it on that side. So 2vy dv dy is equal to v minus 1 on v. 3v minus 2v is v. Yeah. Or can we say v square minus 1 over v is equal to 2vy dv over dy? Okay, we keep all the v term on one side. Yeah. Therefore, we will have 2v square minus 1 dv is equal to dy over y. Okay, and then we do integration. Now, this integration, which is not that obvious, but if you could realize, if I just write this bit differently, 2v over v square minus 1, differentiation over the original term. If you are yet not sure, one more variable, v square minus 1 as t, and 2v dv is dt. This is dt over t. This is dy over y. This is ln t, ln y, assume ln c. Okay, and therefore t is equal to y times c. T is nothing but v square minus 1 is yc. What is v? V was x over y. Okay, so x square y square minus 1 is equal to cy. So x square minus y square equal to cy3, right? Yes, or yeah, cy3. and then you replace the particular value. Y of 0 was 1. That means x is 0, y1. X is 0, y1. Replace it here. 0 minus 1 is equal to 1. Therefore, C is minus 1. Put it back here. X square minus y square is minus y3, or y3 is equal to y square minus x square. Same answer. But had you realized that this is x on y, not y on x, which is not easy. You can't just wake up and imagine or dream about it. Oh, this is x on y. No shortcut here, not at least that I know. Okay. Bit fewer slides. 1, 2, 3, 4. In the previous one, there was a lot, and especially I knew the trick 1, 2, 3, 4, 5. I knew a trick of doing that very quickly. If you were not aware, if you don't know that, few more slides. So again, a heavy question. Can't help with the length. I can help with simplifying it, giving you multiple approach of solving it. Can't help with the length, sorry. Okay. This is how it is. Okay. Any question, please feel free to get in touch. Okay. There is one more question, and then that's it. We will end of the session. Yeah, I'll just finish this last question. Okay. A motorbike is traveling with a speed of 10 meters per second, takes a quick break to avoid a potential accident. Normal scenario, motorbike or car, but car is not that small, slower speed. If the change in the speed is proportional, right? Change in the speed, what do you say? Speed or velocity, we just keep it dv, yeah, is change in the speed is proportional, change in the speed dv by dt is proportional to, proportional is symbol, proportional to the product of the cube of the speed with the time. Speed or velocity, we call it v power 3 multiplied by t. So you got that proportionality equation similar to what you had earlier, right? There was a similar question. Time from the moment the brake was pressed. The speed was reduced to 2 meters per second in 1 second. So from 10, it's going to 2. Okay. The question says how fast. So you are finding the speed. How fast v of t. Yeah. Was motorbike was traveling since the brake was passed. How long? That is the time, but v is given, and how far. So you will, go for the total distance covered at every point. So whenever that happens, you will go for definite integration with the limit. Okay. Right. So how do you form the equation? If the change of the speed, say it says here that it's meter per second, so you are talking about dv over dt, yeah? So dv by dt was proportionate to product of the cube of the speed, v3, with the time, v3 times t, right? When time was 0, the initial speed v is 10, so that's a hidden value given here, right? When t is 0, v is 10. That's given here. Okay, how fast? So you are talking about in 1 second to when t is 1, v is 2, right? You're finding v of t here. How long? 1 second. So v is 1. You're finding the value of t here. And this is when I say when t is 4, from 0 to 4, you're finding the distance, okay? Right. Let's start with the beginning. So we have dv by dt is proportional to v3 and t. Proportionality constant k. dv by v3 is equal to k t dt. Okay, integration. This is v power minus, remember the power thing. So v power minus 2 k t square over 2 plus c, or c1, right? So I multiply with minus 2, 1 over v square minus k t square minus 2c1. Right. Let's leave it like this for now. Okay. And if you want, you could have called C. Okay, let me call this C. So 1 over v square kt square plus c. The first condition, when t was 0, v was 10. So 1 over 100 is equal to 0 plus c. Yeah, so c is 1 over 100. Put it back. So 1 over v square is equal to minus kt square plus 1 over 100. So now only I have to take care of k. If you shuffle that up, which we always can, prior to that we can multiply with 100. So 1 over v square was minus 100 kt square plus 1 over 100. Yes, and therefore v square is 100. Shuffle it up. Let's start with 1. Easier to write. 1 minus 100 kt square. And therefore v is equal to plus or minus, but it doesn't go negative in this instance, so don't worry about the minus. 100 over 1 minus 100 kt square. And you can set 10 divided by root of 1 minus 100 kt square. Right, so that's your kind of particular, but not yet. K is still there. Now we use the other part, remember? So we use this one. Now we have this 2 in 1 second. So when t is 1, v is 2. We use that information. When t is 1, v is 2. You gotta use anywhere here, wherever you like. I choose this one. So v square, that is 400. 1 minus 100. Okay, because t is 1. Yeah. So 1 minus 100k is 100 over 4, 25. So 100k is minus 24. Yeah. And that will leave us k is equal to minus 24 over 100. Or whatever you want to write that thing. Yeah. You can keep it minus 100k is 24 or whatever. And therefore my v will be 1 minus 100k is 24. So 1 plus 24 t squared. That is my particular solution where I don't have any constant. Okay. So when you look at the question, what have you addressed? Yes. How fast this was going. So this is how fast it was going. Right. Okay. Now we use v is equal to 1 to find how long the time t. Okay, so that's one. The next, when t is 1, what is the value of v? Or is it the other way? Sorry, I wrote the other way. When v is 1, what is the value of t? Yeah, how long? Right. So what we have v is equal to 10 divided by 1 plus 24 t square. So 10 is equal to square root of 1 plus 24 t square because v is 1. So 100 is equal to 1 plus 24 t square. 24 t square is 99. So t square is equal to 99 over 24. You can simplify it if you want. T square is equal to 33 over 8. and t is equal to square root of 33 over 8, which is just above 4. So the root will be just above 2. If I got it right. Um, yeah, 33 over 8, whatever that comes as, yeah, whatever that comes as, that's the value of t. Just about 2. You can check it if you like. Sec 8, 4.125 square root. Two point oh three. Yeah, that's the value of t. One more part. The next part where, again, if you go back to the question, how far would the motorbike travel in 4 seconds? In 4 seconds and at 4 seconds, different approach. In 4 seconds, so starting from 0 until the end, you are finding everything. And that's why you need definite integration from 0 to 4. At 4 seconds, how, where is it, or the point, then it's a different story, right? You'll replace t is equal to 4, like we did t is equal to 1 in the previous one, okay? So here we will do integration, but integration, okay, let me write it. So what we got, v is equal to 10 divided by 1 plus 24 t squared. How far? We are finding the displacement. So you have ds by dt is equal to 10, 1 plus 24 t squared. And for ds, leave the 10 outside if you want. The 1 plus 24 t squared dt. Okay, now integration from 0 to 4 seconds. Okay, integration 0 to 4 ds, 10, integration 0 to 4, 1 plus 24 t squared dt. Again, going back to last year formula, integration of 1 over a squared plus x squared dx was written as ln x plus a squared plus x squared, of course, plus c, but definite doesn't have a c, right? Now, one more thing. This was for x, this is for 24. So the multiple of this, if you want, you can write one more step here. 10, 0 to 4, 1 over square root of 1 plus square root 24t whole square dt. So the multiple of x should go down. Okay, so when you try to integrate, the left-hand side is fine. This is s. This part here will be 10 divided by square root 24. And then we have ln x, that is let me substitute the value. Okay, so 10 over root 24 ln x plus square root of 1 plus x squared. 0 to 4. What was our root 24t? Yeah, okay. Okay. And then you plug in the value of 4 and 0. So that will be 10 over square root 24. When you plug in 4, so ln 4 root 24 plus 1 plus 4 square t4. And then you plug in 0. So this is 0. And this will be square root of 1 plus 0. You simplify 10 over root 24 and all that thing, that da thing. Finally, that should give you 7.5. Okay. Another approach what you could have done, just a bit here, you could assume your square root 2040 as x and change the limit accordingly, right? Okay, so that's your how far answer. You know, from the brake applied in 4 seconds, the motorbike would have traveled a distance of 7.5 meters. Okay. Right. I know it's tricky, especially if you have forgotten what you've done in last year, or you weren't strong enough, then you'll obviously struggle. And I'm sure the previous lecturer, Professor William, would have explained that. We had that discussion where he told that no students are aware that flowchart thing, math 11246, and then you build up to the calculus AB 12223 and 12224. Then you have 13217, 13218. Yeah. It's never too late. You got the whole term, right? And you will have to pass the unit. The only way is you make strong your integration concept. If your integration concepts are strong, then you can build up or solving a differential equation. Otherwise, it's impossible. I would not say difficult, I would say impossible. You will struggle at every different question. Okay. Right. Well, then, this is everything. Thank you very much for your watching the recording. Those who could join online, thank you very much for joining online. Good luck. Any doubt, please get in touch. Otherwise, I'll see you next week. Take care. Bye.